Okay, 106. I just made this video, but I forgot to save it, so I have to make it again. F of x and g of x are two functions, and we want to know where their inverses will equal each other. So I'm going to do something crazy here. I'm going to use the idea that inverses swap x and y. So I'm gonna make the claim that if I want to know the x values where f inverse equals g inverse, that's going to be the same as finding the y values where f equals g. So all I'm going to do to solve this problem is I am going to graph f of x, which is 7 divided by the quantity, so use parentheses, negative x minus 1, close your parentheses, and g of x, negative 4x plus 2. So again, my claim is the question wants to know the two x values where the inverses intersect, but that has to be the same as the two y values where the original function intersects, because we're talking about inverses, and that's how inverses work. You swap x and y. So I'm actually being like substantially clever here by solving it this way. I'm solving this problem without having to actually find the inverse functions. That's pretty cool, I think. So graph them both, calculate the intersection point, and you're going to get a graph that looks like this. It's better look like that, and like that, and then one coming down like that. So that intersection point right there happens at the x value of 1.2, but we want the y value. The y value is negative 3.083. And if I calculate the other intersection point, so second trace, option 5 is intersect, enter, enter, move now to the left, so I'm on the other intersection point. That happens when the y value is 9.083. And so those are the two x values where f inverse equals g inverse. And that was a really clever way to solve it. It would be super cool if you thought of solving it that way. And maybe if you didn't, I think you should be able to understand why that works. So those are the two solutions, but we can hit this with the normal approach as well. If you want to find an inverse function, you definitely need to know how to do that. Swap x and y. So write this first equation as x equals 7 over negative x minus 1. But don't do that because you're swapping x and y, so the denominator is negative y minus 1. Now we want to get y stuck in the denominator, so I could do 1 over x equals negative y minus 1 over 7. I reciprocated both sides, took the reciprocal of both sides. Totally, totally legal. And then I can multiply by 7 to get 7 over x equals negative y minus 1. Now, if you didn't like that, another approach you could take is we need to get that y out of the denominator, so multiply it up. So get x times negative y minus 1 equals 7, and then divide the x down, so get negative y minus 1 equals 7 over x. So we get the same spot. Okay, so that, and now let's add 1 to both sides. So 7 over x equals, 7 over x plus 1 equals negative y. So y equals negative 7 over x minus 1 is our first equation. If you did the same thing with g of x, you would write x equals negative 4y plus 2. You would subtract 2 to get x minus 2 equals negative 4y. You would divide by negative 4 to get y equals x minus 2, all divided by negative 4. So you could enter that into parentheses and graph it. And now you can graph both of those and calculate the intersection point and find the x values, and you will get the same exact answer we did before when we found the y values of the intersection point. But that only worked because of the crucial idea about inverse functions that x and y swap.